Isha Sinha, a final year BSc student. From my very childhood, I'd always wanted to become a research scientist and pursue my career in academics in the field of fundamental science. But in this pandemic situation, I'm really worried about the current opportunities in this field. How nice would it be if someone guides me right now?
Hi, I am Krishnendu, a PSC final year student. I am too much worried about my career and future in this current pandemic situation. I dream to join any industry after completing my BSc and master degree, but I have no any clear idea, particularly in this current pandemic situation. So I am totally confused. Can anyone help me?
How should I prepare myself to work in an industry?
What is the mindset needed if I want to pursue academia?
Hi, I'm Isha Sinha, a final year BSc student. From my very childhood, I'd always wanted to become a research scientist and pursue my career in academics in the field of fundamental science. But in this pandemic situation, I'm really worried about the current opportunities in this field. How nice would it be if someone guides me right now?
Hi, I am Krishnendu, a PSC final year student. I am too much worried about my career and future in this current pandemic situation. I dream to join any industry after completing my BSc and master degree, but I have no any clear idea, particularly in this current pandemic situation. So I am totally confused. Can anyone help me?
How should I prepare myself to work in an industry?
What is the mindset needed if I want to pursue academia?
Good morning and a warm welcome to you all. After addressing a few epidemiological, social, economic, and psychological issues through a series of webinars, we at Surendranath College thought the need to deal with the issues our students are facing due to this unprecedented situation. So, dear students, remember, you are not alone. To address to your issues, your worries, your anxiousness, your concerns about your future, your career, and to guide you. Today, Department of Chemistry, Surendranath College, has organized the Student Orientation Program, an international webinar on academics versus industry, choosing the right path. This webinar has been sponsored by Department of Biotechnology, Government of India, under the DBT Star College Strengthening Scheme. Now, I would request our principal, Dr. Indranil Kaur, to deliver the inaugural address. Over to you, sir.
Good morning, ladies and gentlemen. COVID-19 pandemic is tightening its grip every day. The morbidity due to the disease is also showing very higher trend. The deaths due to the COVID-19 and comorbidity has become a cause of concern. Most of the people are advised to remain indoors. Others who need to go out are expected to follow the standard protocol and maintain social distance. The entire education delivery system is under great stress. The majority of the institutions are helplessly waiting for the pandemic to slow down or stop. A few others have resorted to alternate route of education delivery system like online, etc. But the direct education providing is of remote possibility now. Thus, the students are the most confused lot, who are helplessly wanting the normalization of the situation. Moreover, the shrunken market due to the pandemic has also created panic-like condition among the job aspirants. Under this condition, Department of Chemistry, Surendranath College, under the DBT Star Strengthening Scheme, Government of India, has organized this international webinar on academics versus industry, choosing the right path, by Dr. Shudip Pal, research scientist, Intelsin, Pharma Montreal, Canada. I hope his deliberations today will enlighten our students and the participants as a whole, and definitely will be very interesting and very fruitful in coming days to combat with the shrunken situation of the job aspirants, for the job aspirants. I wish the webinar a great success and hope to remain with you and understand about the intricacies of this, the choosing the right path. With this, I hand over to Hari Shankar to introduce the speaker today.
Thank you, sir, for coming to our departmental webinar addressing the occasion and inaugurating this program. On behalf of Department of Chemistry, Surendranath College, I welcome you all present here virtually to our international webinar, Academics versus Industry, Choosing the Right Path, under our college strengthening scheme. Without your graceful presence, it could not have been possible. Now, without delay, let me introduce our today's esteemed speaker, Dr. Shudip Pal. Dr. Pal is actually a medical chemist with sound 11 years expertise in target-oriented synthesis of natural products of biological importance. Dr. Pal secured second position in both BSc and MSc from Presidency College under the University of Calcutta. After doing PhD at CSR, Central Drug Research Institute, Lucknow, under the supervision of Professor Tushar Kanti Chakraborty at IISc Bangalore. He did his postdoctoral research at the University of Montreal. After staying as guest in expert faculty at Sikkim Central University, he is now a research scientist at Intelligent Pharma at Montreal, Canada. He had many publications in various international journals of great repute and has already backed 2 patents. I hope his talk today will definitely enrich our students and all of us alike. Over to you, Dr. Paul. Dr. Paul.
Thank you, Hari. Thank you for the nice introduction. Hello, everybody. So I'm Sudeep. Today, I'm going to discuss about choosing the path between the academics and industry. So both are right actually in their own way. So after class 10, when we take a science subject combination, we have different options of subject like mathematics, physics, chemistry, and biology. But apart from that, we have different subjects like biochemistry, biotechnology, or microbiology, even computer science. But these kind of subjects are actually like tip of iceberg in an ocean. So basically, if I were you, I would be choosing the basic core science with mathematics, because mathematics is becoming much more important in the recent days because of its computer skills and utilization in the computer skills in the higher studies. So the persons who have actually well mathematical skill can explore this kind of computer skill better compared to them who does not have it. But it does not mean who does not have the mathematics as an option cannot pursue those subjects. So after 10, when you are in after 12, you are going to pursue your bachelor's degree. So you have to choose your subject. So in my opinion, it is best to choose the subject which you like to read more. Do not choose a subject specifically because of the job orientation, because job market actually changes over the time. So if you choose a subject which you don't like to read, and after passing out from a particular institution in that subject, you might find that the job prospect of that particular subject is not good at that time. So you would be kind of stuck with your dislikeness, which is not right. So first of all, you have to choose the subject which you like to, which actually you want, which actually interests you maximum. And then you have to choose the career opportunities. For this, you can consult your teachers first. That is the most easiest way to access. After that, if it is possible, consult your seniors who was successful in that field. And also you can go for career counseling. There is nothing wrong in taking career counseling also. So after doing this kind of consultation, you will find a good plan for the future. So I think that everybody has chosen the right subject and want to pursue the subject very well in his BSc, in his or her BSc, and will secure good marks. But what to do after BSc? So after graduation, you can join industry. There are lots of openings in pharma, paper, forensic, or ceramic trade, or biotechnology, this kind of industries. And you can also pursue as an academic school teacher. So I'm not considering here the jobs which are basically like competitive civil services exams, because I am thinking about the students who actually want to pursue the jobs with their subject of interest. So after BSc, if you really want to pursue industry job, it's a good option. But the thing is, down the road, you might not feel it good, because what happens, you have to work parallelly with the master student and the PhD student, PhD employees. So what happens if you want to take, you want to have promotion, so you have to compete with them. And in that case, you are a little bit lagging behind from them because of your educational qualification. So if I are you, I will choose to do the masters, because what happens if you're doing the masters, there will be more prospect because you are getting higher degree, so your job prospect will increase. And the second thing, if you really find the subject attractive, you might pursue higher studies like PhD in it. So after masters, when you are pursuing masters, you think that you are not confused with your or next goal, like you want to join industry or you want to go to academia. What you can do, you can apply for some summer or winter internship in different companies. This will actually help you to understand the nature of working culture in the industry, and which will help you to prioritize your choice that you like to go in academia or in industry. And if I think, like, if you are going to complete your master's and PhD, then you can join academia as a professor or in university or college professor, or also you can be a scientist. In industry, you can be a research scientist as a beginning, and depending on your performance, you can move up to the ladder. But if you're not interested in, after BSc, pursuing BSc, that you feel that your science is not your cup of tea, so you can go always to the BTech, that is the technological line, and you can access engineering sector jobs. If you really like engineering, you can go for MTech and PhD, so you can access engineering academic job or engineering industry jobs. But most of the students after doing BTech goes for the industry jobs. And if you have already taken the BSc and then you are going to BTech and want to pursue MTech and PhD, so it is not good for a student who is coming from the BSc background, because you have to fight with the students who actually have the Bachelor of Engineering. So it becomes a little bit tricky for the BSc pure science students. So if I think that you have completed your master's or PhD and want to join industry or academia, depending on what you want to choose. So first, you have to understand what are the responsibilities in these two different institutions. So whenever you want to learn or want to run a lab, basically you need source of funding, that means money. For academics, it comes generally by applying grants to different organizations like DST, DBT, or CSIR. And in these cases, you have to go through a lots of paper application. It takes time and it's kind of painstaking also. In industry, our source of funding is like client. We call it client. It's like a big pharma or some university or some government organization in the similar way. But here, initially, the process goes through verbal interaction. And if things go well, then we do an agreement. But these works are very fast. If you think about research, then academics, it is more of your like self-motivation. You have to choose your own problems and you have to give your own solutions. So it is kind of good in a way, because nobody will be above you to judge or something like that. But sometimes it is not so good, because if you are doing some mistake, nobody will be able to advise you. But industry, there will be always somebody above you. So it is more of a team kind of atmosphere. And we choose, or the industry choose, the problems that is already present in the market. So whatever we do have a direct impact on the applied field and also on the society. Now, if you think about the publishing, when you are in academics, you have to publish articles in various reputed journals. But industry, we concentrate more on patents, because patents are important for revenue earning. Now, if you like teaching or guiding students, or you like giving, you like evaluation of students, then academics is pretty good for you. Now, in industry, these kind of options are also there. Like with experience, you can mentor the new recruits, which is a good opportunity for mentoring. Apart from these things, the responsibility like departmental works like safety, management, consultation, all these things are present both in academics and industry, which you have to perform with your present research, whatever you are doing. Now, if you are coming to the workplace culture, so nature of research. In case of academics, the research is mainly learning based. Only the basic science is given the priority. In case of industry, it is mainly an applied source. So whatever we do in the industry has an immediate impact on the field. As a pressure, now, when you are going to a new join as a new scientist in academia, so you have a tremendous pressure for publishing. You have to promote yourself, you need to get support, and these things really is pretty tough. In industry also, there is also pressure, because all the projects here are deadline based. But as a new recruit, you will have time to adjust with the atmosphere. You will not be given very big responsibility when you are newly joined. You will have the time, but in industry has a bottom line. You need to deliver after some time. Timeline. In academics, whatever you do, it generally they are lengthy to get the results, but industry is very timely based. So it is very fast paced research progress. So if you really are interested in a fast paced research atmosphere, then industry is good for you. Now, communication. Most of the time, what happens, like in academics, you need to secure your data or research activities because you need to publish papers. So it always the discussion remains in between very small group. But in case of industry, it is always team-based behavior. So whenever there is a problem, the discussion goes over whole industry, like with different employees with different activities or different experience. So it is mainly team-based atmosphere. If we go to the collaborative behavior, academician has a larger opportunity for collaborations because the collaboration goes from a different fields, biology, chemistry, physics, like any kind of fields they can go. And this kind of collaboration sometimes creates some kind of trouble, like which collaboration will get much contribution from the other. But in industry, what happens as a whole, it doesn't need any kind of collaboration. So if we really need something very specific, then we go for this kind of collaboration. In goal, the goal is for academics is mainly autonomy oriented. So if you are a supervisor, most of the time it is your decision which only matters. But in industry, what happens, the idea is the main thing, like the idea which is the best would be taken. So it is mainly larger shared goal. Competition in academics obviously very high. You have to prove yourself among all the others. In industry, there is competition, there is no doubt, but the problem is the goal is more important. You have to get the result. That is the priority rather than competition. Now, achievement in academics is purely personal. So whatever you achieve, it will be with you. So if you're a person like want to keep your work value to you, it is better in academics. But in industry, whatever it happens always as a team-based achievements, because you will never find a medicine. Whenever we sell a medicine or any industry sells a medicine, it goes in the name of the industry. It doesn't go in the name of the group who actually delivered it or invented it. Now, individual impact and freedom. So obviously academics is self-responsibility. You have to decide your work, you have to decide your success. So most of the time it is you who will take the failures, self-responsibility for the failures and the success. But industry always is team driven. If somebody is failing, then there will be somebody who will try to move him up. There will be always somebody who will actually try to move him up. So industry is more team based. Ideas. Sometimes academic ideas are pretty good, but sometimes they are very difficult to adopt in practical field. But in industry, the problems always come from the applied field. So whatever the solution, it should be applied in the field. Now, if we look at the flexibility of career advancement, then the most important thing is time management. So time management is academics is personal. That is, you can choose your time, what you want to do. Some people prefer to work early, some people prefer to work late. So this kind of freedom is there in academics, but industry has a fixed working hour. There are two reasons for that. First thing is that if you're in the lab, even if you are alone, this is not good for safety reasons. Only 2-3 persons if you're working in the lab, this is not good for your safety measurements. And the second thing is you cannot work in a time where there is no medical assistance is available. The second thing is cost versus productivity. If only 2 persons working in a particular lab, then all the instruments has to be kept on for these 2 or 3 persons. But productivity is not that much compared to when all the industry is working or the full functional industry is working. So industry always appreciates fixed working hour. In a way, it is good. Like if anybody likes to be a time-to-time worker and enjoy your time in your own way, then industry is a good choice for you. But if you like to be personal, like if you want to use your time in your way, then obviously academics is better for you. Now the advancement. So in case of academics, what happens, you are stuck with similar kind of research. So you become expert a particular field, that is very good. But it is very difficult sometimes in academics to move from one particular field to others. But industry, it is not like that you have a very broader experience, like depending on your skills, on your experience, you will be changed from one project to another, which is good to get more and more skills. And also it is flexible in the way like you may have started your career as a researcher, but you can slowly go for management position or go for consultation position. But in academics, this kind of change is very difficult to get. Salary, that is also the most important thing. So both are competitive now, but in terms of increment, incentive or bonuses, industry is sometimes good because it is completely depends on your performance. So if your performance is good, these things will increase rapidly without any time. But in case of academics, sometimes you have to wait for these things even if you're performing good. So it depends on your choice, like what you want to do. So if you have gone through this, so you can find that it depends completely on your priorities in life, like how you want to spend the time. You want to spend the time like teaching and learning with teaching, or you want to learn more with a mentor. You have to recognize your own strength, like if you're excellent in managing your own time, how to utilize them, then it's very good in academics. But if you want to learn how to manage time, then working in more structured environment like industry is better. Your personality actually depends, like you are more positive about your work. You want to take the complete share of your work, you don't want to share it, then academics is good for you. But if you want to share your success with others, then industry is good. And in a way, it is again more team-based atmosphere. But the most important thing is your long-term thinking. That is what you want to be after 20 years. So that actually will help you to decide where do you want to be in the academics or industry. So figure out well where do you want to be after a long time. So as I'm in pharma industry, so I try to give some insight into how actually the drug discovery and development is done in industry and how different kinds of branches, specifically biology and chemistry, actually fits in this process. So whenever actually a disease is emerged or a disease we want to study, we have to identify the disease. And there is two approaches to treat the disease. The first thing is called observation-based disease, observation-based approach. In this case, what we do, we actually know from the beginning that this compound is active against the disease, and without thinking anything, we just apply it to the medicine. Like sometimes now we are using chloroquine for the COVID-19 situation. So we don't know actually what is the mechanism of action, how it works. We just know it actually stops some or inhibits some amount of this COVID-19 spread. So we just using it. But this approach is slowly becoming obsolete because this kind of approach is not good for patient cells because we don't know the side effects of this kind of approach. So what we are going to discuss here is target-based approach. So first, what we do in the target-based approach, we find the disease and try to find out what microorganism actually is causing it. When we find this microorganism, we try to find the target. So PhD medicine or doctor or biologist do this kind of things. So if you're any branch of these kind of things, you have an opportunity to get in this kind of job. So what is basically a target? So when we find the microorganism, we try to find out the mechanism of action of this microorganism in the body and try to inhibit one particular process by blocking a particular protein or a nucleic acid or enzyme or RNA or DNA, something like this. So it is basically blocking a particular molecular structure. So that is the target. So we need to find this particular protein where we can inhibit the particular process. Now, if we know the target, what should we do next? So when we find the target and the mechanism of action, we try to find out the target validation. Target validation means we hypothesize a theory that this way it is going to attack and this way it is going to operate. And we try to find out by molecular labeling or fluorescent marker that this is the right way. Because if we don't do this target validation and after doing lots of work, we find that this is not the actual mechanism of action, then we are in trouble. So target validation is important thing in target-based approach. So when this target validation is done and we know that we have the right target, what we do, we actually need a process to determine the activity of a particular molecule against the microorganism, which is called assay development. So we do this assay development. Now we completed our target identification. we completed our assay development, so we know how to determine them or to measure the activity of the molecules. So we now treat lots of molecules with this target and try to find out the hit molecule. Hit molecule is the molecule which actually bind with the targets, so to give us a activity. Now, lots of active molecules are there which actually binds with the target, but it does not give us enough response, which is sufficient for the screening assay. So we need a particular efficacy value for this kind of response. And these hit molecules are those which actually generate this kind of threshold value of this efficacy after binding to the target. So when we know that this type of hit molecules are available, so where can I find this kind of hit molecules? So generally we look for natural products from the plants or animals. We look for chemical libraries that is already present in different labs. We go for computational medicinal chemistry, like we design the molecules and actually do some docking or molecular study with the protein to find out particular design. So these are the three major sources for the hit molecules. Now we have done the determination of hit molecules. Now how we'll do that? It is actually a particular hit molecule, so we need to do the hit identification. This is actually done using high throughput screening. You can see at the right, there is a high throughput screening machine. It actually screens thousands of samples within a very short time against the screening, and the screening is complete to give us a number of hit molecules. So biologists actually do these kind of things. And when we get these hit molecules, like we know that these molecules are going to be active against this particular protein or this particular target, what we do, we actually try to now prepare these molecules in the lab. Now this, when we do the prepare the molecules, the purification is done. In industry, the purification goes through two processes mainly. One is crystallization, another is MPLC, that is called medium phase liquid chromatography. If we need much more purer compound, then we go for HPLC, that is high performance liquid chromatography. Now, after doing this hit identification, we try to find the lead molecule. Lead molecule is the molecule which have the necessary core structure for the activity. That means if this unique character is present in the molecule, it will be active. How much it will be active, it depends on other factors, but the molecule will be active at some amount. So this, if you look at these two structures here, so you can find out that if you compare these molecules, you can find this phenyl ring and oxygen is common to this structure. So in lead, we try to find out this kind of common feature, which will give us the lead compound to find out that this will be the most active structure. So if we find this lead, so what we'll do the lead optimization. What is this lead optimization means? Because we need to now optimize this character. So we have to take care of the solubility. It should have to be optimum value, because if you have more solubility, then it will be dissolved in water. It will not pass the membrane barrier. If it is less soluble, then it will not go through the, it will not dissolve in water and will not pass through the membrane. So you need an optimum solubility conditions also. And this is the most important part of the discovery. So which is the basic properties by which we will do the lead optimization? So there are two properties we need to consider. One is pharmacodynamics and another is pharmacokinetics. So pharmacodynamics basically deals with the effect of the compound on the organism. So basically it measures the activity, that means potent compound. But already, as it is a lead compound, most of the time pharmacodynamics is okay with those. But the problem is pharmacokinetics. Pharmacokinetics deals with the fate of the molecule in the body. And most of the molecules actually fail in this particular property. So pharmacokinetics basically is based on 5 different properties, that is absorption, distribution, metabolism, excretion, and toxicity. So absorption is nothing that's just in a normal way. You can find out, like if you take a tablet and just take it orally, so it will go through your mouth to intestine and then to your blood. And this movement through lipid barrier is called absorption. Now this actually relates availability of the compound in the bloodstream, because more of you can understand, like when you are taking the tablet, when it will go pass through your intestine, some of your material is going to be lost, and the concentration in the blood is always going to be less. So this proportion of the molecule that is present in your blood and the amount that you are taking, this ratio is called bioavailability. So you can understand if you're taking the molecule, or if you're taking your drug orally, obviously your bioavailability is going to be less. And if you are giving this molecule directly in blood through injection, so your bioavailability will be 100%. But you can understand that injection is not a good option. Whenever you become sick and go to a pharmacist, have you ever asked like, I need 15 injections for 5 days? It does not make that good, because if you want to give injection, you need specialist person. You have to find the vein and put the injection syringe there, and nobody likes to give syringe each time into the body. So obviously you have to go for tablet or syrup or other kind of formulation. So if you have poor bioavailability, it needs to overcome through design. That's very important in pharma. As I said, route of administration is very important. If you give oral, you have mainly your bioavailability will be less, but if you have injection, you will have your 100% bioavailability. So your poor bioavailability needs to overcome through your design. Next is distribution. So your drug has gone to the blood, and now it will go to the different parts of your body. So it will go to the target also, but it will be distributed in other parts of your body. And if you find that if your off-target distribution means other target distributions are more than your desired target, then that is not good for your body. So you have to then again address the issue and redesign again your drug so that it becomes more available to your target site. So after distribution, the most important thing is metabolism. Metabolism is the important part where we actually convert the food into energy. So if your metabolism process recognizes your drug as a food, then it's a problem. So you have to find something, your drug, that is stable under these metabolism conditions, but still how far design is good, it is obviously going to be metabolized in some amount. So you have to think that you get the activity and then it's getting metabolized, it's fine. But before getting activity or getting your product, your drug metabolized, then it's a problem. So you have to find out the right stability condition through design. After that, it is the excretion. So whenever there is a foreign particle, obviously your body is going to excrete them. So these biotransformations actually occur in drugs, liver, plasma, or gut wall and kidney mainly. Most of the time, what happens, you give your drug into your body. This gets oxidatively metabolized, and you add more and more your oxygen to the systems. So what happens, your molecule is becoming more and more polar and soluble in water and gets excreted from the body. Last portion of this admit property is toxicity. Toxicity means whenever your drug actually enters the blood, it binds to the plasma protein. And most of the cases, your drugs 99% actually binds with the plasma protein of the blood. This is very important because what happens then, your unbound concentration of the drug in the blood remains very less, and it is good in a way that you will not get toxicity. But you think that if your unbound concentration of the drug in blood is more, then your toxicity level will increase. So it is very important to design your compound which will show high plasma protein binding. But if your drug is binding too much strongly with the plasma protein, then the problem will be that when it is going to the target, it will not be freed from the plasma protein. So you need something important or factor in your compound where it will bind to the plasma protein, but when it will go to the target, it will release from the plasma protein and bind with the target. So I think you can understand that how difficult is that, this kind of design. That's why most of the drugs it fails in this kind of admit properties. So lots of chemists and biologists and pharmacists actually worked hard and failed lots of times, and depending all of their observations, they have come to a rule which actually helps us to design some molecules with sustainable pharmacokinetic properties. This is called rule of 5. So the first thing is your molecular weight should be below 500. Its lipophilicity value, that is the log P value, should be less than 5. It should not have more than 5 hydrogen bonds. It should not have more than 10 hydrogen bond acceptors. So the reason is why it is called rule of 5, because you can see it doesn't have 5 points, but you can see that whatever the points they have told, most of them contains a number 5 or the multiple number of 5. That's why it is called rule of 5. So you think that you have designed a molecule which actually give you a good pharmacodynamic properties, and it is also give you sustainable pharmacokinetic properties. So now it is ready for testing. So first it goes to preclinical testing. Preclinical testing means we actually test these molecules against animals like mice, rat, rodents, or chimpanzee, or even monkey, and try to find out the toxic effect like safety pharmacology or drug metabolism and pharmacokinetic studies. So, and compare with the in vivo studies that is done in the lab. Now, the thing is, most of the time people do this preclinical testing with the other PK studies. So that actually saves us time. And in this time, we actually work on the formulation also, because we need to find out how we are going to deliver this drug into the body. So after this, if your compound passes the preclinical testing, it goes for testing on humans, which is called clinical trial. And doctors actually perform those trials. Now, clinical trial actually divided in 4 different phases: phase 1, phase 2, phase 3, and phase 4. Phase 1, we try this drug in the volunteers, healthy volunteers, and try to find out what are the side effects first. And then if it succeeds, we go for phase 2, that is for the patients. Now, if it succeeds in patients, then we go for phase 3, that is we treat the large scale patients. And then the last remaining is the post-registration monitoring, that is the after effect after treating or after giving better drug effect, what is any kind of side effect is there or not. So again, doctors actually do these things. So both when clinical trial it is passed, then we just give the approval, and we just apply for the approval and launch the drug in the market. And we need in this case is the MBA, lawyer, and patent officer. So this kind of jobs is also very lucrative, and you can pursue this kind of studies also later on to find a better salary structure or better career advancement. So in this all time, we have discussed like how actually the pharma industry works, and also like academic and industrial differences. Let's talk about just industry academic collaboration, how actually it works. So generally, I am from the synthetic background, so I'm doing some synthetic studies which have been done in academics and then explored in the industry. So Taxol is an anti-cancer drug. You can see the structure; it is very complex, and it is heavily oxygenated polycyclic diterpenoid. And this compound actually earned a revenue of $55 billion up to January 2020. So it's very important. And taxadienone is one of the intermediate which actually can be used to prepare this taxol molecule. So I'll just compare this taxadienone synthesis in academia and then how it modified in the industry to get a better yield. You can see the earlier synthesis. So the best example is 13 mg or 14 mg, we'll say, it has been obtained in the last step of this synthesis. So if you think about your tablet size, it is generally 100 mg or 250 mg or 500 mg. So with 14 mg, you can't even treat one patient. How are you going to treat thousands of patients? So we need a process where we can prepare gram scale preparation of Taxol. So what are the challenges we are facing in this Taxol gram scale preparation? First is long synthesis. We don't need in industry very long synthesis. We always need small number of steps. The purification should be easier, and it should be we should get the product as fast as we can. And crystallization is the best option in the industry. Yield. We don't like low yielding steps, but if there is, it is better if it is in the beginning of the synthesis, not at the later stages of the synthesis. Cost, we generally don't like industrial costly reagents if there is option, but it does not mean if we really need it, we are not buying it. We're definitely going to buy it. We're not going to prepare it. Now the time. So we don't like lengthy reaction time in the industry. Industry is always like reaction should be faster and isolate the product and go for the next reaction. And reaction condition, the reaction condition should not be very drastic, like not very exothermic, not very dry, not very hazardous, because those are kind of limitation we have in industry. So we always like reaction which is pretty much robust and easy to do. So I'm just going for the industrial route optimization for the taxadienone. So the process starts with the 2-methyl-2-butene treated with the bromoform to prepare a dibromocyclopropane ring. So academic scale, they have started with 69 gram of bromoform, but industrial scale, you can see 401 gram of bromoform they have used. So to increase the volume of the decrease the volume of the reaction mixture, industry actually decrease the level of heptanes, decrease the amount of olefin so that we don't have remaining starting materials. And when the isolation has come, academia did not isolate the product. They have done the crude reaction mixture for the next, use the crude reaction mixture for the next reaction, but industry isolated the product almost around 400 gram, which is quantitative. Now the next step is very important. Now this is a simple elimination reaction of the bromide to give you the diene. It is done with the N,N-dimethylalanine under 150 degrees centigrade. But you can see this reaction is very, very exothermic. And if you want to do this reaction in 400 gram scale, you can make a big explosion in the lab. So we need to find some solution in industry. In academics, it is fine. You are doing in 30 or 40 gram of scale or 50 gram of scale is fine. But in 400 or 500 gram scale, or even 1 kg scale, it's really difficult. So they have come up with a solution. This is called continuous flow reactor. What we do here, basically, we take the dry bromide and the N,N-dimethylalanine in a pot, and then we transfer it to a tube in a coil, and then heat this coil up to 150 degrees centigrade. So basically what we are doing actually using a reflux condenser type of system. So slowly the cold water or cold reaction mixture goes there, heated up, the reaction is done, and then it goes out for the system. So by this way, what happens, the local concentration or local heat concentration is avoided, and you can avoid the explosion kind of situation. So chemical engineers are actually design this kind of flow reactor. So if you want to pursue this kind of chemical engineering stuff, you obviously have a good future in the industry. Next, it is a simple reaction of the ethoxy cyclohexenone. Here we simply just add this phenyl magnesium bromide to the ketone, then you remove the ethanol group from this oxygen to prepare the phenyl cyclohexenone. In this case, we actually remove the ether in the industry. The ether was replaced with the methyl tertiary ether. By this way, they actually got a better yield. Not only that, the reaction was performed very well within 1 hour. That's quite important. After that, this bromo actually added to this phenyl cyclohexenone through a 1,6 Michael type of addition, or you can say reductive effect type of coupling condition. The industry academic scale was like 8.8 gram, whereas industrial scale is like 57 gram. In this case, the ether was replaced with THF, which helped to utilize the commercial catalyst when in the academia they are preparing the catalyst. The academia took 10 hours for this reaction, but industry has completed this reaction within 3 hours. So yield is around 13.5 gram, 86%. For academic. For industry, it was 85.2 gram, which is also 85%. Now we are going to a simple methyl addition, not simple, like methyl addition, 1,4-Michael addition, and quenching of this hydroxide with the TMS. Now this reaction has been done with the trimethyl aluminum with copper catalyst with the presence of the ligand, and we industry were struggling to make this compound because of the quenching issue, because it is such a highly acidic condition that little bit moisture, if it is present, it is just destroying the reaction mixture. So what they have done, they actually done the quenching with reverse addition with trimethylamine so that the condition of this reaction becomes basic. Academia took 10 hours for this reaction. Industry has done this reaction in 3 hours. So you can see the yield 1.3 gram for academics. For industry, it is 85.2 gram, which is quantitative yield. Now the most important thing, the addition of this acrolein to this alpha position of the cyclohexanone. Not only that, you are going to oxidize it subsequently. Academic scale was 3.2 gram, industry scale was 25 gram. Now industry used acrolein dihydroacetal because it is more stable than acrolein. Academia took 24 hours and industry took 5 days. So you can understand that if it is important, industry also takes time to complete a reaction. So it is not always a rule that industry always make the reaction very quickly. So academia got 2.3 gram, 94% yield, but industry got 91 gram yield, 61%, which is not good because the yield is decreasing in the later stages of the reaction. After that, this is a Diels-Alder reaction in presence of a Lewis acid catalyst. The reaction goes well. Academic scale was 2.3 gram, industrial scale is 19.4 gram. Industrial purification was done by distillation. They are lucky to find out that the two, that is the one that is the required compound, actually is crystallizing under the heptane condition. So both academia and industry actually has done this reaction within 6 hours. Academia got 47% yield and industry got 22% yield, and that is again a problematic step because it is almost at the end of the reaction step. So it needs to be done better. Now, after that, you can see that it is a simple reaction of making the triplet, and you just do a Negishi coupling to incorporate this methyl with the required substrate. So in this case, industrial purification was done by crystallization from heptane, and in the academia, they have actually separated these two molecules, separated the molecules through column chromatography. So academic scale was like 2.4 gram, industrial scale is 4.8 grams. So both of them almost come to the similar scale. So this is not good for industry. So you can understand that quite the problem is coming. So first step was done in 1 hour, second step was done in 5 hours. In industry, it is almost remained the same, but the second step is done in 3 days. Again, it took time. So yield is like academia 2 gram and industry, it was like 3.9 gram with the 82%. So we can find out that how the academic results we actually utilize in the industry to make bigger batch of the compound and how to get a better or larger yield for these compounds is important to get more and more of the compounds for treatments. So that was my actually basis of the whole talk. So if you have any questions further, you can then ask.
Thank you, Dr. Pal. It was really very apt and lucid talk. I think the students must have been enlightened by the end of your talk. You explained very lucidly the pros and cons of both academics and industry. And now I think the students must have cleared a bit of their confusion. You have also told them how to think about their long term goal and choose subjects according to their choice, how to go about their career. And your talk was really very direct, and students really must have benefited from your talk. I appreciate it. So I would now request Dr. Lolita Dash of Department of Chemistry to moderate the questions, the tons of questions which we have received in the chat box, and ask you, sir. So over to you, Lolita.
Thank you, Aditi. Am I audible?
Yes, yes, you're audible. Very clear.
Okay. Okay. I, I welcome you, Dr. Pal, for this question and answer session. Are you ready, Dr. Pal?
Yeah, sure, go ahead.
So I move on to question and answer session. We have many questions in Google Form, chat box, and YouTube Live. I am asking one by one. First question from Google Form goes, after this COVID pandemic situation, the pharmaceutical companies will be flourish. So the job opportunity will be increased in these companies or not?
Actually, the pharmaceutical industry is already flourishing. There is nothing new in that because already there are diseases which actually is much more important than also COVID-19, like cancer or HIV or tuberculosis, where the mortality rate is much more. So people are working on them, and still the work is going on. So the pandemic situation is actually decreased the recruitment procedure, because you can understand that lots of people cannot come or movement is restricted. That's why. But I think it is already flourishing. So there is an obviously an increase. There is also an addition of individuals. So obviously that is going to increase. Obviously, there is no doubt.
Okay, thank you, Dr. Paul. Hope the student is satisfied with this answer. Next question from one of our student is, I am a student of chemistry department. After completion of BSc, higher studies or industry, which is the better way to get job in this present situation?
The present situation, or the thing is, depends. It's what you want to do in a way, like what you like to read. Because if you're looking for jobs, as I have told earlier, if you're looking for jobs and then choosing the subject, then it is a problem. Try to find your interest first, like what kind of subject actually interest in chemistry in you, and then you try to find out the opportunities. Because if you are looking for jobs only, you might not be happy after getting a job also, because you need to do something innovative or something interesting there, and if you don't like it, and then you will not like it. So first try to find out the interest in your subject, which particular portion of your subject makes you interest, and then actually you go for looking for jobs in that particular area. I think that is much better approach, but you can choose anything, industry or academics, it doesn't matter.
Okay, thank you. Next, I move on to the question from Google Chat. The question is, which field we create more successful research career, in academics or in industry?
It completely depends on your outlook. I cannot tell you like what you want to do. Like if you want a research career, like your personalized research career, you have to go to academics. But if you want to learn, or if you want to be in team-based atmosphere where you want to say real applicative problems, you have to be in it. Lots of people actually migrate from industry to academics, academics to industry. So these things will go on. So with the time, I think you will understand what is your goal or what you want to do with your life, and then you can decide. So there is nothing like it is better than the other, or this is better than the other. It depends completely on your viewpoint, like what you want to do.
Okay, thank you, Dr. Pal. Next question is the biology oblique pharmacy oblique chemistry. Which subject in undergraduate is best suited for aspirants of pharma industry? How does knowledge of mathematics act as an advantage in this kind of industry?
Okay, that's a good question. The thing is, like, if you're in a pharma industry, if you want to be in pharma industry, so obviously your knowledge in biology and chemistry is very important, because this go in parallel. And mathematics is important in the sense because most of these things are now are becoming computer based or computer software based. So if you know mathematics, you can know some commands or some software tools or some acquire any code very easily, which is difficult if you don't have the mathematics. That's why mathematics is very important in every aspect of the field at this moment, like when you are doing higher studies.
Okay, thank you. Thank you, Dr. Pal. Next, I take a question from YouTube Live. While this pandemic, maximum time we hear about human trial. My question is, one of our students asked this question. My question is, if vaccine has ill effect, then if person dies, is the researcher or company liable for compensation, or just because they are affected and chances of death is more in the case, that's why they try?
No, that's a very nice question. Like these things are not so easy like it looks like. Like they are going for the vaccine trial. So as I have said, when they are going to clinical trial, they first have to apply to the government. Then they approve it. After that, you have to sign some papers, like the person who to whom they are going to this vaccine or they are going to give trial, they have to sign some ethical papers that it is something happened to him, the company would be responsible or the government would be responsible. They will have some amount of compensation for that. So all these things are there. So it is not just a process that we can take some random people, some from the roads that are going and just take, okay, there's a vaccine on you. So it doesn't occur like that way. So don't worry about that. There is a typical procedure for it. It should be shortage of time, all those things, but there is procedure. So everything is like organized, not a disorganized way. These things are done.
No. Okay. The last question is, are there any specific examination we should crack for getting jobs in any industry? One of
No,
our student asked.
in industry jobs generally comes from the academic students. So you have to clear the exams in the academic. So industry doesn't hire you in that way. If you are like past your masters or your PhD, then you can apply directly to the industry. There is no certain exams like that. So you don't have to worry about that to get an industry. So you have to score good in your masters or do a good publications or to do good research in PhD. That's the important criteria for this. There is no means writing exam or practical exam, something like that. Only thing is interview.
Okay. Thank you very much, Dr. Pal. Hope students get clear their doubts. Many of the questions have been answered. I think there are many more queries, but we are running short of time. So I wrap up the question answer session. Now it is the time for vote of thanks. I would request our IQC convener and coordinator of Activity Start College scheme, Dr. Shuchandra Chatterjee, to deliver the vote of thanks. Over to you, Shuchandra Di.
Thank you, Lolita. Am I audible?
Yes,
Yes,
you are
ma'am.
available.
So, a warm and blissful afternoon to you all present here virtually from various locations for today's international webinar presented by Department of Chemistry, Surendranath College under DBT Star College Strengthening Scheme. You know, saying thank you is more than good manners. It is actually good spirituality. And I'm really privileged to get this opportunity of delivering vote of thanks in these webinar to all the dignitaries and beloved students who have witnessed this program as a memorable and successful event. And to all those who have directly or indirectly contributed towards this event, though my words are not enough to express my gratitude properly. On behalf of DBT Star family of Surendranath College, first of all, I extend a really hearty vote of thanks to our honorable speaker today, Dr. Sudeep Pal, for his very informative and motivational speech. Thank you, Dr. Pal, for your most useful deliberation. Hope it would help our students utmost to choose the right option between academics and industry according to their individual mindset. I am immensely grateful to our college authority, the governing body, for their encouragement and support. A special mention to our respected principal, Dr. Indranil Kaur, for truly being an inspiration and standing as a pillar of strength. Thanks are due to DBT, Department of Biotechnology, Government of India, for granting us this fund. We are really indebted to them. Special thanks are due to all the faculty, laboratory staff, and students of not only chemistry, but all the other three departments of DBT Star family for their joint and tireless effort to make this webinar happen. And there were always some people behind the scene, starting from flyer designing to trial video preparation, certificate making to Zoom meeting conduction and live streaming. All were efficiently managed by our most proactive and enthusiastic faculty members, the faculty of chemistry department and the dedicated members of technical team without any external help. So kudos to all of them. Next, I thank our beloved students, both from our college and other institutions. Their spontaneous presence has no doubt made this event really meaningful. Last but not the least, valued viewers, all the dignitaries, we owe you a lot for being with us, witnessing this webinar. Without your gracious presence, this event would not have been successful. So with this, let me stop here. Again, rendering my heartfelt gratitude to all of you present here virtually with a high hope, a hope of breathing deep in a COVID-free world very soon. Together, we will fight the battle and definitely come out victorious one day. All be safe and healthy. Take care. Thank you, one and all. Thank you very much.
Thank you, Dr. Chatterjee. Before you leave the meeting room, two small announcements. One is regarding the feedback form. The feedback link is there in the chat box as well as in the YouTube comment box. and in our college website, that is Surendranath College website. The feedback link is active now, right now, and it will remain active till till 7 July is today 12 noon, and it will remain active till 11:30. Okay, so 11:30 p.m. today it will remain active. And to get an e-certificate, filling up the feedback form is absolutely necessary. And also we really need your feedback, dear participants, so that we can improve and we can focus on the topics which you want to know, and focus, channelize our webinars, channelize our thoughts in that direction. So please do fill the feedback form, an earnest request. So before we leave the meeting, another announcement is about the webinars which are going to happen next. Uh, we are going to organize today evening. Today evening, we have Economics International webinar organized by Department of Economics on life and livelihood of the migrants in India, lessons learned from the pandemic, 2:30 p.m. to 4 p.m. In Zoom cloud meeting. Next, we have a webinar to be arranged by Department of Physics, and very this is going to be this we have tried to do something different. It's an outreach program which we have arranged for high school and as well as college students. Department of Physics has arranged it under the DBT Star College Strengthening Scheme, and we'll be having with us Dr. Devi Prasad Duwari in this talk. So hope to see you all in our upcoming ventures. Stay well, stay safe.